Hello, my name is Imran Aslam. Today I am going to give a demonstration on looped piping flow calculation application. First of all, I will explain the installation procedure from the setup file for this application, and later I will explain the main feature of this application. So if you already have downloaded the setup file from my website www.petrosoft.com, then you can simply double click on the application setup file. The application installation wizard will be launched on your screen. From the language section, you can select the appropriate language. By selecting the appropriate language and pressing the OK button, it will take you to the license agreement page. Again, selecting the appropriate option and pressing the next button will take you to the information page. Again, you can press the next button. There it will take you to the application desktop shortcut page, where it is asking to create a desktop shortcut for this application, which you can create a desktop shortcut during the installation, and therefore you can run the application straight away from the desktop shortcut later on, any time in the future. Then press the next button. It will take you to the final step of the installation, where upon pressing the install button, the application will be installed on your computer within few seconds. Since I already have this application installed on my screen, I will simply cancel out this application wizard and go to my desktop, where I already created the desktop shortcut of this application earlier during the installation, which I will just simply double click the application desktop shortcut icon. The application will be launched on the screen immediately. First of all, let's look at the menu options in the menu bar. The first menu option under the file tab is there are three further sub menu tabs are provided under the file tab. The first menu tab is the new menu tab, which is used to launch the new instance of the application. For example, if I close the application, then I can go to the new tab to launch the new application or initiate the new application from the beginning. Similarly, the next option under the file menu is a save option, is a save button, which can print or save the results into the PDF file on your computer, and the exit button is to close the application. Then about button on the menu bar is to review the information about the developer and the application. And the third menu tab is the help tab. When you press the help tab, you can open up the application manual, which comes along with the setup file. There you can read out the detailed guideline on how to use this application with the pictorial representation of each section, and the instruction how to fill the required information or input fields in order to run the application. So I will go back to the main application window. So basically this application is developed to calculate or estimate the split of the flow into multiple headers across the flow path. So basically it happens many times in the facilities where multiple lines or required to split the flow through different loops or different routing into the plant or into the facility, and that's where you require to calculate the split of the flow into each segment or the branch of the piping segment. So let's, for an example, just look at the exemplary schematics of the looped piping system or a network, where you can see that there is an inlet header where the main inlet gas stream is coming in, and further it gets split up into three branch loops beyond the point A, and the three loops are named as loop 1, which is ABE, and the loop 2, which is tagged as ACE, and the loop 3 is tagged as ADE. So you require to split the flow into similar kind of different looping or a piping segments and that's where it requires to calculate the split ratio or the amount of flow that will be passing through each branch according to its isometric layout and geometry and the piping geometry. So that's where this application is helpful to calculate all the necessary process parameters in that situation. So now let's look at the application. This application has only mainly one page where the user can provide the required input variables. Also on the same page the user can get the results after the calculation. So starting from the input section on the top left hand side corner, under the input section the user need to provide the gas flow, pressure, temperature, inlet header or inlet piping size, the wall thickness of the inlet piping, and then user can select the piping material. There is a broad range of piping material or a list of piping material that is commonly used in the industry is provided in the drop down list, and the user can select an appropriate piping material from this given list of piping material from the drop down menu. Now the next input is the corrosion inhibitor, which is normally or widely used on the plant to prevent the corrosion rates inside the pipeline or in the internal piping walls due to the different nature of the fluid or the corrosivity of the gas component or the gas that is flowing through the piping network or piping sections. So basically there are different modes of corrosion inhibitor injection can be applied to in the industry. Most commonly sometime a continuous injection of any corrosion inhibitor chemical is required, and sometime it can be intermittent service, sometime it is intermittent service. So here the user can select the appropriate option of the corrosion inhibitor injection, whether it is a continuous basis or an intermittent basis. From the drop down list the appropriate selection can be made by the user. Now moving further, the molecular weight of the inlet header gas or the inlet or the incoming gas is to be provided, and the liquid fraction of the gas stream. Basically the gas may be in a two-phase flow condition, or it may be an associated gas which may have some condensate or condensed water or other liquids present inside the gas. So here the liquid fraction can be provided in this input section. The next is the liquid density needs to be provided by the user, and also if the gas contains any sour gas components like carbon dioxide or hydrogen sulfide, then the user can provide the mole fraction of these two corrosive corrosive components in the gas. And the next section, input section, is to define the configuration of the branch or the loops through which the gas is required to split up. Here in the first section, as shown earlier on the schematics, loop 1, which is designated as ABE, that's where the user can specify the piping material of that branch loop of the piping. Again a list of piping material is provided. The user can select from the list. Then user need to provide the piping outside diameter, the wall thickness of the piping, and the pipe length. So again this branch piping can be of different sizes and of a different length. It is not necessarily that these branches would be of the same size and the length always. So it can vary in the size and the length. So here in this section the user can specify the size and the length accordingly. Then again for this branch loop piping, the user can provide the condition of the corrosion inhibitor injection. Again the selection can be made from the given list of options from the drop down menu. The similar information can be provided for the loop 2, which is designated as ACE in the next section. All the information are mainly the same required information as given for the loop 1 or the inlet header, and similar information can be provided for the third loop of the piping segment. Now here an additional two checkboxes or a checkbox is provided in each section of the loop 2 and the loop 3, as you can see. So these checkboxes are provided in order to specify that if this loop exists in the network or if it does not exist in the network. So the user can basically check or uncheck this checkbox to specify whether this loop calculation is required or whether this loop exists in the in your calculation or not. So again, you can omit or remove any of the two sections or both the sections simultaneously as required. But for this demonstration purposes, I will consider both the segments are already installed, and I am going to calculate the split of the gas flow through each segment, basically through the three piping segment as shown on the image, on the diagram, on the schematics. Now once this information is provided in the required fields of inputs, then the calculation is ready to perform the calculation. To perform the calculation, the user can press the calculate button. All the calculations will be performed immediately, and the results of each piping segment, including the inlet pipe, loop 1, loop 2 and loop 3, will be calculated and populated in the respective field under each segment, where you can look at all these important process parameters. So one of the main governing process parameter will be always velocity concern, which is which needs to be checked or verified during the calculation, which is erosional velocity limit. So again, for the inlet pipe and all the required three headers or the loops, the velocity check will be performed at the same time during the calculation, and the validation results are populated under each piping or a loop segment sections, stating the actual velocity, either it is greater than the erosional velocity or it is less than the erosional velocity. So if it is less than the erosional velocity, then you specify the right size and the length of the piping segment. If it is greater than the erosional velocity, like in this case, if we look at the inlet pipe section down below, I can receive an error message or a warning message here stating that actual velocity in the inlet pipe is greater than the erosional velocity, which means that the actual velocity conditions are exceeding the erosional velocity limit as per the API. So therefore I need to take some actions in order to rectify this issue or address this issue appropriately. So there are several different ways where we can cope up with this situation of higher velocities. I will not go in much detail of what are those governing factors. Simply I will change one governing factor here. As you can see, I will go to this corrosion inhibitor section of the input, where for the inlet header it is selected as continuous flow through the inlet header, but there is no corrosion inhibitor. So it says that the continuous operation without a corrosion inhibitor injection. So this was the selection or the input I made earlier during the when I was specifying the parameters for this inlet pipe. So here, as just an example, this is just one factor. It is not the only factor which can be used to cope up with this condition. It can vary from different conditions from time to time or according to your requirements and the need. Here, just for demonstration, I will just simply change this option to the continuous flow or a continuous operation of the pipeline, but with the corrosion inhibitor injection. So once I select or change the option here, then again I can press the calculate button. Once I press the calculate button, I can see immediately the error message has been removed, and it is shown with a green background color stating now that actual velocity is less than the original velocity. So basically I have taken a necessary action or to cope up with this higher velocity concern causing the erosion or the erosional velocity issues. But this is not only the one parameter, the other parameters may be the sizing of the pipe or the flow rate of the pipe or the temperature and the density. All these factors actually govern this important phenomena, but I will not go in detail for that one. Maybe another video I can demonstrate all these technicals related to that. Here the main focus is to explain and explain the main feature of this application, how to use this. So once this calculations are done, the user can again alter all the or any of the given input conditions to check and to validate or to calculate the other results for different scenarios and different conditions. So for example, if I change the piping segment or a pipe size of any of the loop, for example, if I change the pipe segment of the loop currently it is I will change the size to maybe some smaller size. I will say smaller size and then check what happens. So once I change the pipe size and then I press the calculate button, and now you can see all the three loops are showing a red warning message stating that the actual velocity is exceeding the erosional velocity limits, which means that of course now the inlet, the incoming flow rate for the given set of gas properties are actually higher than the required capacity of the pipeline. So here I can take some actions on the inputs and review the calculations again. Just for now I will just simply refresh the calculation by going to the file tab, pressing the new button. Again the new instance of the application is launched, and I will just correct the input over here on the corrosion inhibitor, selecting the continuous operation with the corrosion inhibitor injection, and then I will press the calculate button to resume the calculation and bring the calculation to the same status as it was before. Now once the calculation is done, and the user can press the print preview button, which is given on the main screen, to launch or to open up the print preview window where the user can review the print of this results. And basically the 2 pages result or 2-page report is generated for this results. Once the results are okay and you wanted to save the file into the PDF, simply you can press the print button given on the application main page, or you can go to the file menu tab. Under the file menu tab you can press the save button. The results will be printed out or saved into the PDF file where you can save it on your computer. So once I press the print preview or print button, the results can be printed out in the PDF form. As you can see on my screen, I'm having this PDF file open in front of me with the results printed on the paper. Now moving back to the main application. So here are the main features of this application. Further, the details of how to use and how to vary or alter the different sections of the inputs can be reviewed in the manual, which is associated or given along with this application. Thank you very much for your time and patience. I hope you have liked the videos. Please subscribe and like my channel, and for more chemical engineering applications please visit my website. Until then, thank you very much. Bye bye.